Hello. So we are back. Remember this project? So this happened a few years ago when during a live stream I tried to bring a power supply which can be replicated by everyone. Now remember how this project ended? I mean, ended fine. We fixed it on some point, but let's just remember. So this was a live stream. You can see the chat here, yeah. So we built a power supply and was the moment to test it, yeah. Good. And that's what happened. This was a live stream. You can believe that? It was insane. I mean, the power supply just smoked out. Anyway, we found the perfect power supply cheap. £3 power supply. You can believe that? I mean, with £3, you can't even buy like the diodes. But let's have a look. Let's see. This is a £3 linear power supply, 0 to 30 volts, 0 to 3 amps, which can easily modify to 5 amps. I mean, check here. £3. Let's have a look from where I bought it. And that's the Amazon. This is the power supply, £3.80 actually. And we can see it here. Look pretty nice. So we're about to start and test it. I mean, it looks fine. So we should do it, right? I mean, there is no way, even if you buy only the components, there is no way to beat this price, like £3 and something. So let's do it. finally ready. So actually everything is on place. We have the transformer. Everything looks fine. Now it's something what you don't know. We are on a different day. After I finish, I try to modify because many of you guys probably doesn't have a transformer. Just to make this usable with a DC power supply, like a laptop power supply. And the thing goes wrong. And I burned all three chips, like all three. The way how this works, so every chip, this can work with normal voltage, like plus and minus, but not here. Here, it's working with differential voltage. So you have the ground, the minus, then you have minus, then you have plus. Yeah, it's a little bit more complicated. So I try to modify it, and what I try goes wrong, and I burn the chips. And on that point, the only options was to order another one. It's not even worth to order the chips. I mean, for £3, I just order another one. So let's test it together. Yeah, I'll plug it. So our power supply is on. Let's use the on-screen multimeter. You can see there the voltage. Plus and minus. You can see we have like 17, and we can adjust the voltage till 0. And back. We can go with the voltage a lot over the multimeter, yeah? The problem is, you have the power supply, now you need something to see what is going on there, yeah? So what I will gonna use, I will get the old power supply, this one, yeah? And we will gonna use this. So we did this, you know, this is like 3-4 pounds, it's no more than that. You can see the voltage and current. Let me solder this on this board, and we're gonna use this to see the voltage and the current. Give me 1 second. All done. So now we have a visual indicator about what's going on here. So here is the voltage. Okay. Up to 23 volts. Okay. Yeah, because the transformer is 24. Yeah, that's right. That's right. Now, if you have this one, how do you connect it? Very simple. You have, I connect one wire to the plus, yeah, like immediately after the rectifier bridge. Then this is the output voltage plus. Then you have the ground to ground, and then you have the big wires which is checking the current to ground. So actually my output is, this is ground, the output, and plus from the connector. Okay, but let me first, yeah, before we are checking, because to check the current, it's something else. So checking the current, we need a heatsink on the transistor. Yeah? If you don't have a heatsink, it will blow up, or it will get shorted. But you need a big heatsink, yeah? You need a big one. If you have one, it's fine, no noise. If you don't have one, then you have to use a smaller heatsink with a fan. So I do have a smaller heatsink and a fan. Yeah, this one. What's wrong with this one? Now, in order to use this, this is a 5 volts fan. On the board, you see this? You have the fan connector there, 24 volts. So this is the regulator for the fan. Now, if you have a fan, 12 volts fan, you use a 12 volts regulator. This is like this is 7824, and you have 7812, 7805. We're gonna use 7805, which is a 5 volts regulator for the fan, yeah? So let me replace this and use a 5 volts regulator. Now the best tool to get the holes back, it's a toothpick, yeah? We're gonna use a toothpick. I mean, you can use weak wire, but this is faster, you know what I mean? Perfect. So we're gonna use this one. Now we replace this, the regulator. The next problem is how we are putting the transistor to the heatsink. And this can be an issue. But let's do it on a final way. Perfect. So the transistor is soldered to the heatsink. Now the next step is to connect the fan. Okay, we screwed up. So actually I don't know why I remember those read regulator 7805 is going up to 40 volts, but it's not. It's only up to 24 volts. So I use a little switching power supply, which is like 1-2 pounds. But anyway, you can use like one transistor and one Zener diode to get 5 volts out for the fan. So you see the fan is spinning. Yeah, the transistor is cold. Now it's time to test the current. What do you think? What do we have here to check the current? We have this. This is an adjustable resistor, so we can pull out some current from this power supply. So I connect the resistors, one wire here and one wire to the plus, and now we can follow the current. What happened? Wait, what happened? What did I do? Why? Why always? This is the second video when I'm dealing with power supplies and it's blowing up on my video. Okay, something sparked. I don't know why, because everything here is properly made. So something sparked and goes off. The story of my videos. I can't believe I done nothing. The diodes are good. Okay. The transistor is good, but I seen a spark here. I swear I seen a spark here somewhere. You know what? Let me plug it back, yeah? Let me plug it back. It's still working, but the fan is not spinning. So do you think the fan... So here we have 2 volts. You know what? Let me stop the recording and check what blew up there. Okay, I found it. So you see, without any connection, like any connection, you see this track just blow up. This track is from ground. I mean, I had nothing to do with the ground. It just blow up by itself. So this ground is the ground for the fan, which is going to the wire to this little regulator. So either the regulator is shorted or the regulator is shorted. Yeah, let's check. No, it's not shorted. Okay, you know what? Let's check together. Let's come with the power supply, which is on screen. Let's come with 5 volts first. 5 volts. Let's see if we have any short there. So a minus, plus. And we have no short, that's the thing. Rising the voltage. No, the regulator is dead, I can't believe. That's crazy. Don't tell me this killed my fan. Don't tell me that. Don't tell me actually this killed my fan. Where is my fan? Minus, plus here. The fan is dead, I can't believe. What? It's taking like what? It's taking like 1 amp and 1 volt. or the regulator is shorted. Yeah, let's remove the regulator first. Okay. Then I suppose those power supplies are cheap for one reason, from one reason. It works for like a few minutes. Yeah. Still good, still decent. Okay, let's see the fan. Let's see if the fan. So this thing, it was made to protect my fan, my output. Yeah, the fan is still working. I can't believe. Yeah, the fan is still working. At least. So what blew up here? The chip? No freaking way. So actually what blew up on this board, it's a capacitor. So check there. You see that capacitor? Actually, this thing it blow up. This one, you can see, has a crack on it. You can see it? Wow, okay, that was quite a long journey for that capacitor. Quite a long journey. So do you think my regulator is still good? Yes. Oh, this is the output. Wait. This is the output capacitor. 1 second. Input, output. Okay, let's remove the capacitor and attach the board again. Okay, let's use a proper calibrated wire to build up the truck again. We have to build up the truck to make it great again. So this is a ground track which is going here. Now we're using a proper calibrated wire, and now it should be fine. Now let's solder the regulator back. Perfect, all done. Let's try one more time. And the fan is spinning again. I can't believe. So we have cooling. Now we have the voltage and the current. I think now it's time to start playing with our resistor. So here we have a current resistor, quite a big one. But how can I do it so you can see? Perfect, now you can see, yeah? Now let's increase the current. So the current is going up 1 amp, 1.3 amps, 1.6, 1.7, 2 amps, 3.2 amps. Now we are pushing our luck, 3.5 amps, 3.6. I still cool, like 50, 60 degrees. Yeah. Okay, the question is, sorry, if you ask me about the current, yeah, it's limiting the current. So we have 1.3 amps and we can limit the current. And when we are limiting the current, the voltage gets dropped. You can see, which is normal. Yeah? And increasing the current, yeah. Okay, good. Give me one second. So now the question is, and someone asked on the video today, we spoke in the morning briefly about this power supply, and someone asked on a comment, how do you think you can get at least 5 amps with this PCB? Of course, magic. I explained him. But, when you are speaking about taking current out, yeah, you have to ignore the driver. Yeah, this is the driver adjusting current, voltage. You have to ignore this and you focus on this. This is giving you the output current. Yeah, you understand? This doesn't matter. This, it will give you your output current. So what I'm gonna do, because I bought one more, like how I told you in the beginning, because I got the chips burned. Yeah, I do have a second transistor. So the idea is to connect the second transistor on the parallel mode with this one. So basically, logically speaking, we are doubling the output current. Actually, it's not double, but if this is capable of 3 amps, we will not have 5 amps, but we should have at least 5 amps. We will not have 6 amps, but we should have at least 5 amps. Yeah. So let me grab the transistor. So we're gonna solder both transistor on the heatsink. So let's calculate 20 volts or 5 amps is like 100 watts. I don't think this fan can take out 100 watts. 100 watts we can take out with a heatsink from a gaming PC. We can take out that 100 watts. But this is a normal heatsink, probably from a 30 watt CPU. So not sure how much can handle this heatsink, but let's try it. Let's try it. Perfect, perfect. Now let's wait to cool down. Okay, great. So now we have to solder the transistors. And we have to solder on a parallel mode. Now the right way to solder the transistors. The transistors are not the same. Yeah, they are not the same. So we should use a very tiny resistor, like 0.02 ohms, like about this kind of power, like about 5 watts, 10 watts, in the emitter, yeah, then connect them together, then comes to the board. Okay, that's how the right way to connect transistors on a parallel mode. Yeah, because they have different. Even they are the same, they are slightly different. Transistors are like people. Yeah, looks the same, but actually are slightly different. But in our case, yeah, like a raw test, we can just connect them on the parallel mode. Perfect. Now the emitter is no point to solder there. I can solder here on the output. Yeah, it will be same thing. Perfect. Now let's solder the fan. Perfect, we are ready. So let's test it. Perfect. Now let's plug it. Okay, it's working. It's working. The fan is spinning. We're fine. We're fine. Let's increase the current. Yeah. Let's increase the current. And the current is dropping because I have a limit. Yeah, because I have a limit. I have a current limit. Let's go up. 3 amps. 3.5. 4.2. 4.5 amps and it's so hot. This thing is so hot. You know what? You know what? Ay, 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 ay. Okay, just give me 1 second because I need. I have to do it in a different way. The transistors are fine. No problem. Let's try it like that. Five amps. Check there. 5 amps. 5 amps. 5.2. 5.3. And it's going under the limit, I believe. 5.3 amps, you can see. And the resistor is smoking. You can see it's smoking? It's smoking. 5.3. Low, I can keep the finger on the transistors. So the transistors are like 40 degrees, no more than 40. That's how you modify a power supply, yeah? And that's how you can do it. Obviously, I have the current limit, so I can lower the current. Obviously, the voltage is getting dropped, like usual, according with the Ohm law. But I'm happy because a £3 power supply, it's affordable for everyone. And that's how you modify. If you buy one, buy two. Or, I don't know. Yeah, instead of buying a second transistor, just buy two. Still 5.3 amps. This is mad hot. I can feel it from here. And this is just, I can keep the finger. I mean, I didn't think, like this kind of fan is so efficient. I mean, just think this has to pull out 100 watts. Crazy. $5.2, 5.3 amps. But the transformer. Okay, no, my transformer. I don't think he can. Yeah, and the voltage is going up. Okay, yeah. No, my transformer. So the voltage is getting dropped because of my transformer. But let's lower the voltage. Yeah, like 50 volts. $4.5, 5.2, you can see. So the power supply, this outputting, if it has enough power from the transformer, lol, okay, that one is hot. The transistor, I can keep the finger, are hot, are like probably like 60 degrees. Wow, this is mad hot. I mean, the air, I think you can use it like a heater. Now let's check with the thermal camera. I'm gonna tell you a few improvements what you can do with this, because I checked with the thermal camera already. Yeah, not of like 78, 70 degrees. But I can still keep the finger on it. Let's lower the current. Let's have a look together with the thermal camera. I mean, yeah, probably even look at the diodes. Look how hot are the diodes. Now my regulator is hot. The heatsink is decent. You can see it. The transistors. Now look, check the transistors. Are not that hot, but that resistor is very hot. You can see it. So the resistor is hot. The diodes are hot, so I suppose you can replace the diodes for 5 amps. Just swap the diodes, and here you have two resistors which are getting hot, those ones, which are creating the negative power rail. Okay? So one more time. Yeah, 5.2 amps. You can see it's going up to 5.2. So that's how you build a 5 amps 0-30 volts linear power supply. Yeah, my transformer is not that great. This is a small one. 24 volts, I believe. Okay, so that's how you do it. That's how you do it. 23 volts is going up to 23. But when you start pulling the current, the voltage will get dropped. Yeah, so that's why you need a higher voltage transformer. Probably like, I would say like 30 volts, 45 volts, just to use the power supply from like 0 to like 25 volts, which that's enough. I mean, you're looking to fix laptops or whatever. 0 to 25, 0 to 5 amps, I think it's enough, yeah? Well, let me unplug it. Okay, so what I will modify in order to use this. This resistor is fine, it's no problem with this resistor, but I will put probably one 10 watts resistor, this one, yeah? Then you have here two resistors. One is 220 ohms, and no, one is 82 ohms and one is 220 ohms. And you should replace them with 1 watt resistor, yeah? I mean, are getting quite hot. The diodes, I will use something solid. I will show you some solid diodes. I mean, you can use something like that, or you can use like a rectifier bridge. You can, no, this is a small one. You can use 5 amps, use a 10 amps rectifier bridge, yeah, or 10 amps diode. So this resistor, those two resistors, this one is not that hot. You can leave it like that. And the fan, hard to say. Preferable is to not use a fan because it's noisy. Just use a big heatsink. But if you have to use a fan, just use here whatever regulator. You can use 24 volts regulator. You can use 12 volts, so you can use a computer fan. Yeah, 7, 8, 12. It's 12 volts regulator. Okay, so there you have it. I will say thank you for watching. Like and subscribe if you like the video, and if you have any questions, yeah, just ask me. If you want more modification on this one, just let me know. I will hold it, and if it is to do more modification, we can do. So see you on the next one. Bye.